Hello everyone and welcome to the chemistry classes. My name is Trilok Kumar Thakur and I am your chemistry educator. So dear student, if I am going to tell you about my expertise, so my expertise is the whole chemistry, right? And I have 5+ years of teaching experience as I taught in the Vedanta Innovations Private Limited as a chemistry teacher, including I work with Bansal Classes Private Limited as a academic head, including the chemistry faculty, right? So as of you know that dear student, in the previous classes we have started with the new chapter, that is ionic equilibrium, and in this chapter we have done with the Arrhenius acid basin theory. So just I am going to give you the briefing about the Arrhenius acid basin theory. So in the previous class we discussed about the substance which can produce H plus ions in the aqueous solution is known as what? Arrhenius acid, right? And if I'll talk about the Arrhenius base, means what? The substance which produce OH minus ion in the aqueous solution is known as what? Is known as the Arrhenius base, right? On the same year we have discussed about the neutralization reactions, right? So we have taken the two things. The first one is acid and we are reacted with the base and that will produce the salt and the water. So as of you know that the neutralization reaction can be defined as the reactions of what? H plus ions and the OH minus ions, right? So now today we are going to start with a new topic, that is Bronsted theory. Bronsted Lowry theory, right? So what is the meaning of this theory, dear student, right? The first thing is that in the case of Arrhenius acid, we completely talking about the H plus ions including with the OH minus ions, right? But in the case of Bronsted theory, we are going to discuss about the two things. The first one is proton donor, right? And the second one is proton acceptor, right? Now I am going to talk about, right, proton donor means what? Proton donor means what? In the case of acid, that is proton donor means what? H plus ion. Which ion? H plus ion, right? So we are going to talk about the only two things, right? In the terms of acid, that is the substance is donor, and in the terms of base, the substance is what? Acceptor, right? So I hope it is very clear to all of you, my dear student, right? By the definitions, that is the one substance is that will donate the H plus ion and the other substance is there that will accept the H plus ion, right? So now dear student, please write down the definitions of acid. What is the meaning of Bronsted acid, right? So we can write the definitions as the substance which have tendency which have which have tendency to donate proton, right? Which have tendency to donate proton in any solvent, right? So dear student, as you remember that in the case of Arrhenius acid, we have fixed the solvent, that is aqueous solution. But in the case of Bronsted theory, right, we don't have fixed the any type of solvent, right? So we simply, right, have written that is any type of solvent, right? In any solvent they can donate the H plus ion, for example, right? So there are basically different types of the state of the ions, right? That is the first one, the acid which have neutral charge. It means what? It does not have any ions are there. There is no negative charge, there is no positive charge. But the acid which is having what? Which is having a negative charge. So that type of acid comes under the what? Anionic acid, right? And the thing is that let us suppose that the acid which is having a what? Positive charge, right? So that type of acid comes under what? That is cationic part. So there are three conditions are there, right? The acid which does not have any type of charge. So for example, let us suppose that you are having acid, right, that is H2S, right? Suppose that H2CO3, right? you can also suppose that HNO3, and you can also taking as HNO3. So as of you know that, right, there are 4 compound I have written over the board, right, that is H2S, H2CO3, HNO2 and HNO3, but it does not have any charges over there, right, there is 0 charge, right. For that reason it comes under what, it comes under neutral, right. But we can suppose that we are having acid that is HS minus, right. You can suppose that we are having a HCO3 minus, right. You can take it as H2BO3 minus, and we can take it as H2PO4 minus, right. So dear student, you can easily see that there are 4 acid in the anionic part, right. Anion means what? Anion means the acid which is having a negative charge. Simple thing is that, right. Now the on the same way, if I'll talk about the cation, right. So cation means what? The acid which is having a positive charge. It has which charge? It has positive charge. So suppose that the example of cationic acid, that is what? NH4 plus, right. We can take it as PH3 plus, right. We can take it as CH3 COOH2 plus, right. Now all the 3 acid which is having what? Which is having a positive charge, right. Now we are going to see, the thing is that which is very very important, that is we are going to find out the conjugate acid conjugate base pair. This is very very important, right, because you know that in some of the questions they are going to ask about find out the conjugate acid base pair. So how we are going to calculate, right. Let us suppose that you are having the acid that is what? H2S. We have taken H2S, and now we are going to mix with what? The solvent, that is water, right. So water is behaves like what? Water is behaves like solvent, right. Which one? Solvent. Now the thing is that just we studied regarding the acid, that is the substance which donate proton in any type of solvent, right. Or proton means what? Proton means H plus ion. So we can easily break this H2S as what? As H plus ion, and what? As HS minus, right. You can easily break. Now the H2S, from H2S, H plus ions is going to donate what? H plus ion is going to donate to H2O. So you know that if water is reacted with H plus ion, then it will produce what? Hydronium ion, that is H3O plus ion, right. So in the product what you get? You can easily get HS minus plus H3O plus, right. Now so the thing is that in the reaction, right, there are 2 parts. The first one, this is what? This is acid, right. So we'll study later the substance which accept the H plus ion is known as what? Is known as base, Bronsted base. So H2O is accepting what? H plus ion. So this is what? This is behaves like a base, right. Now the concept of conjugate acid and the conjugate base, that is what? That is after donating the H plus ion, the remaining substance is known as what? Conjugate base, right. In the case of acid, after donating the H plus ion, the remaining part is what? HS minus, right. So this is what? This is called conjugate base, right. This is conjugate base, right. In the case of base, so after accepting the H plus ion, right, after accepting the H plus ion, whatever the compounds are formed, that is known as what? That is known as conjugate acid, right. So now dear student, you can easily write down the conjugate acid base pair. How? So let us suppose that there is a conjugate acid base pair, means what? H2S HS minus, right. Again you can write H2O and 3O plus ion, right. So, this is what? This is what? This is a conjugate acid, conjugate base pair, right. So, now I will give you another example. You can easily see how what happens actually, right. Then after we can wind up the classes for today, right. So, let us suppose that another example is HS minus plus, again we are going to take out the solvent as a what? Water, right. Again HS minus is what? HS minus is behaves like a acid, right. This is what? Anionic acid, right. This is acid. So, another one is behaves like what? Another one is behaves like base, right. So, again from HS minus, H plus ions is going to donate to what? Water, right. So, after donating the H2 right, H plus ion to the water, it will produce what? S minus 2 and again what? H3O plus ion, right. So, again what I told dear student, after donating the H plus ions from the acid, and the remaining part is known as what? Remaining part, that is S2 minus, is known as what? S2S minus is known as what? Conjugate base, right. Is known as conjugate base. And the thing is that after donating the H plus ions, right. So, after donating the H plus ion to the water, the accepting part, that is the product that is formed, that is what? H3O plus. So, this is behaves like conjugate acid. So, again if we are going to write down the conjugate acid base pair, so we can write what? HS minus, right, and the thing is that is S minus 2, and the other one is what? H2O and the H3O plus ions, right. So, this is a conjugate acid base pair. So, I hope dear student you can easily understand all the topics whatever you discussed. So, basically today discussed that is what? Regarding the Bronsted acid theory. So, in the next class we are going to study about the Bronsted base theory, right. So, bye everyone and take care, meet you again in the next classes.